Hello. So right now we're looking at acceleration, and what we know before we read the problem, what we know is that acceleration equals a change in velocity over a change in time. Now my physics professor, excuse me, I have to take a drink of water. My physics professor said to work a word problem, first you need to read it and get an idea of what the story is. And then read it again and list what you know and what you don't know. And then look at your list of equations and see if you can pick the equation to use. And then use algebra to solve your problem. Now we have it a little bit easier here because we just have this one equation, but let's still follow the same path if we can. So an object initially at rest increases its speed to blah, 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 in blah. What is the acceleration of the object? It doesn't matter what these are, it just helps me get the story to say we have an object that starts out at rest, increases its speed to something in some amount of time. And then what's the acceleration? Okay, so I am going to go through and I'm going to say, okay, the initial velocity is that it's at rest. You probably can't see that really well. The initial velocity is that it's at rest. And then it increases to a final velocity or speed. And it does this in a certain amount of time. And then they want to know what is the acceleration. So acceleration equals the change in velocity over the change in time. Sorry for that noise. So I left this one uncolored on purpose because they told us a final velocity and an initial velocity. Now some professors don't use F for final, I for initial. Some of them use just a plain V for final and a 0 for initial. So you can pick whichever one your professor uses. And the time I'm going to go ahead and keep as change in time because they just give us one time. They don't say at this time and at that time. So that means that we have our initial velocity here and our final velocity here, and then we've got our time. So I am going to say 360 meters per second because that's our final velocity, and then initially at rest, so that's our initial velocity. And then divided by our time, which is 4.5 seconds. And you know what? I forgot to do what my physics professor said. We're supposed to list what we know and don't know. So when I see initially at rest, I list out, okay, initial velocity equals 0 meters per second. And then it increases to this speed, so final velocity equals 360 meters per second. And then in that many seconds, well, I know seconds is a measure of time. And then they say, what is the acceleration? So acceleration is question mark. So this is my list. Now, it would help all of you physics students out there if you memorized what units go with what symbols. So meters per second go with velocity. You got to memorize that. It's going to help so much. Meters per second squared go with acceleration. Seconds goes with time. All of that, if you already know it, it'll help you identify what you need to identify in your problem. Okay, so 360 minus 0 is 360 meters per second, and then we've got 4.5 seconds. So I am going to look to see what, I'm not going to show the calculator because this part's pretty easy. 360 divided by 4.5. And I get, hold on, I've got it in scientific notation. Let me change that real quick just so I can be sure. 80 meters per second, which is meters per second squared. Good, because meters per second squared is the unit of measurement for acceleration. Now, I don't know how your instructor feels about significant figures, but 360 has 2 and 4.5 has 2. 80 has 1. So in order to make it have 2, I have to put a decimal here. So 80 meters per second squared. Okay, please remember that in the lower right-hand corner in settings, you can slow down the playback speed. And I'll see you in the next video.